Good afternoon, my YouTube viewers. What we're going to talk about in this video is the Friedman test, which is a non-parametric test. And what the Friedman test does is it examines differences in rankings across multiple treatments or conditions. And what we're going to do is we're going to make a program in Python to demonstrate the Friedman test. But before we do that, we're going to have to import libraries that are needed to actually execute the program. So the first library that we're going to import is NumPy NP, which is a numerical library, and it also creates NumPy arrays. And then we're going to import Pandas SPD, which is a data processing library, but it also makes data frames and series. We're also going to import matplotlib.pyplot_splt, which is a visualization library. And finally, from scipy.stats, we're going to import Friedman chi-squared. So scipy is Python's scientific library, and stats is the statistical module within scipy, and Friedman chi-square is a function within the statistical model. So what we're going to do is we're going to simulate data for 3 groups applied to the same subjects. But before we do that, what we have to do is we have to set the seed. And the reason why you set the seed is because every time you run the program, you want it to initialize to the same values. So in order to set the seed, you have to type np.random.seed brackets 42. And then we're going to define some variables. So subject IDS equals np.arrange 1, 11. So that's going to be 10 subjects. And treatment 1 equals np.random.normal brackets 50, 5, len subject IDS. So that's the scores for treatment 1. And treatment number 2 equals np.random.normal brackets 55, 5, len subject IDS. So that scores for treatment 2. And treatment 3 equals np.random.normal brackets 60, 5, len subject IDS. So that scores for treatment number 3. So the normal indicates it's a normal distribution. And the 50, 55, and 60, those are the means of the 3 treatments. The 5 is the standard deviation. And the length of the subject IDS is the sample size. So the sample size is going to be 10. So now what we're going to do is we're going to perform the Friedman test. So stat, p-value equals Friedman chi-square brackets treatment 1, treatment 2, and treatment 3. And then what we're going to do is we're going to print the results. So we're going to print Friedman test results, chi-square statistics, and the p-value. So we're going to go down here. So your chi-square statistic is 9.6, and your p-value is 0.008. So that means that there's a significant difference between the 3 treatments. And you can see by looking at the box plot that has been created that there is a significant difference. The median of group 1, treatment 1, might be around 53 or 54. The median of treatment 2 might be around 52 or 53. And the median around treatment 3 might be around 58. So there is a significant difference between the means of the 3 treatment branches. So that's why the p-value was so low. And that's why if it was a hypothesis test, then what would happen would be null hypothesis would be rejected, and the alternate hypothesis would be accepted. So now what we're going to do after we've printed off our values, we're going to create a data frame for visualization purposes. So we're using pandas. So data equals pd.dataframe brackets, curly brackets, subject colon, subject IDS, comma, treatment 1, colon, treatment 1, comma, treatment 2, colon, treatment 2, comma, treatment 3, colon, treatment 3, comma, and then we're going to melt the data frame for easier plotting. So data melted equals pd.melt brackets data, comma, id vars equals subject, comma, var name equals treatment, comma, value name equals score. And now we're going to create a box plot, which I've already shown you, is plt.figure brackets fig size equals 6,4. The title is treatment score distributions. The X label is treatment. The Y label is score. The grid is axis equals Y. Line style equals dash. Alpha equals 0.7. And then we're going to create the box plot as plt.boxplot brackets treatment 1, treatment 2, treatment 3 in square brackets, comma, tick labels equals treatment 1, treatment 2, and treatment 3 in square brackets, comma, packed artist equals true, and box props equals dict, bracket, space color equals light blue. So now we're going to add annotation for the p-value, plt.text, brackets, 2, comma, max, brackets, data melted, square bracket score, minus 2, comma, p-value equals the p-value, and comma, font size equals 12, comma, color equals red, comma, HA equals center. So now we're going to show the plot. It's plt.tightlayout and plt.show. And so we've already shown the box plot, but you can see that the box plot has 3 treatments, treatment 1, treatment 2, treatment 3. You can see that there definitely is a significance difference between treatment 1 and 3 and treatment 2 and 3. Although the difference between treatment 1 and 2 is not that necessarily that great. So, but in this case, if it was a hypothesis test, the null hypothesis would be rejected because it is less than 0.05, and the alternate hypothesis would be accepted. So that concludes this video. The next video is going to be another non-parametric test, so I hope you decide to watch it.